Okay, and this next video is on the product rule. And again, continuing with my sort of building us up to the chain in a more intuitive way than I did in class. But we have our product rule. If we have f of x times g of x, we get f times g prime times the derivative of x plus f prime times the derivative of x g. And our cue here that we want to see is functions being multiplied. That's our cue, if we see things being multiplied. So first one, we want to take the derivative of x plus 1 times x minus 2. Well, let's call our x plus 1 f, and let's call our x minus 2 g. Well then, f equals x plus 1, f prime, we can just use our sort of power rule for this. The derivative of x is just 1, the derivative of 1 is 0. So we just get that, and then we look at g equals x minus 2, g prime, again, the derivative of x is 1, the derivative of negative 2 is 0. And now we can put everything into place. We get f, so we have x plus 1 times g prime of x, which is just 1, times d of x. And I will actually show us in this video how d of x can change things a bit, because in our past video all we saw was 1. But then we have f prime of x, which is 1, times d of x, times g of x, which is x minus 2. And here we have our x plus 1 times 1 is just x plus 1, d of x is just 1, because the derivative of x is just 1. And then we have plus x minus 2. Same situation, we get 2x minus 1. There's our derivative of that one. Moving down, let's start using some of our trig rules. Again, two functions being multiplied, we have f, we have g, f equals x, f prime equals, actually let me go back up and do something else. Let me say that this is 1 dx, and then this is 1 dx. Just to be a little more formal. So then this would be 1 dx, and then we have g is secant of x. The derivative of secant is secant x tangent x dx. And now we just put everything in place. We have f, which is x, times g prime, which will be secant of x tangent of x dx, plus 1 dx times secant of x. And then just clean it up a bit. We get x secant x tangent x plus secant x. And just in case this comes up on any multiple choice things, what common factor do we have in both of our terms? This is one term, this is our second term. Both of them have a secant in them. We can factor out a secant. We get secant x all times x tan x plus 1. Just in case that comes up, you can factor out. Okay. Next one. D over dx. Just going to put this little squiggly there so y'all know the separation of my problems. So we're taking a lot of space. We have x squared tangent x. Two functions are being multiplied together. Oops, let me choose different colors. F, G, F equals x squared, F prime equals 2x dx, G equals tangent of x, G prime equals secant squared of x dx. And now we just put stuff in place. We get x squared times secant squared of x dx plus 2x dx tangent of x. And then just making it look prettier, we get x squared secant squared of x plus 2x tan of x. Again, we could ask ourselves, what's our greatest common factor in both of these? Well, we have an x, so we can factor that out. We get x secant x plus 2 tangent of x. The factoring may or may not be optional. I just want you to be exposed to it. And then our last example, this is where I'm going to start bringing in the chain rule. But we have two functions multiplied together. We have f, we have g. F equals x squared minus 1 squared. F prime, here we're going to be careful because we have this x squared minus 1 all squared. So we can just use the power rule to say this is 2 x squared minus 1. But now it's not just, well, it is still dx. But let's look at what our x is, our inside is. That's really what this is saying. Because dx is going to be the derivative of our inside, which is 2x. So here dx is changing. We're using the chain rule because the inside is 2x. And now we'll look at g. G is a normal one again, x plus 3. G prime equals, G prime equals 1 dx. And in this case, this dx is just 1. All right, and start putting stuff in place. We have f, x squared minus 1 squared, times g prime, which is 1 dx, plus our red one, 2 x squared minus 1 dx times x plus 3. And start cleaning it up. We get x squared minus 1 squared. And for our purple, the dx was just 1. But now for our red, we're going to be careful because our red dx is 2x. So I'm going to rewrite this as 2 x squared minus 1, 2x, x plus 3. A lot of y'all will try to distribute at some point here. That is not what I'm going to do because I like factors. The more simplified, the better for the most part. What I will simplify is, I see we have a 2 here, a 2 there. I'm going to multiply those together. That gives us 4. And then we have this x. 4x times x squared minus 1, x plus 3. And there's our derivative. And this is using our product rule.